recording again. Okay, well, let's look at the definition of this. So first, let's circle. We want all the outcomes where the sum of the two dice getting 4 or less. Well, that's going to include all of these. And you can see this one's where there are 5, and this over here, this lower triangle is going to be more than 5. So then, now that we've identified them, we can write the definition of the event as a subset, where we just list them. And there's 1, 2, 3, 4, 5, 6, and that corresponds to these 6 there. Okay, so what is the probability of this event? Well, maybe I didn't give you a chance, but it should be fairly straightforward to see that the probability of this event is going to be the number of outcomes in the event, which is 1, 2, 3, 4, 5, 6, divided by the number of outcomes in the sample space, which is 16, which it's going to be 3/8. So that's it for this issue. Okay. Oh, here's one sort of more general question. What is the probability of any single outcome event? Those are called simple. These are called, a single outcome event is called a simple event. Okay. Bit off track here. Okay, we're going back to looking at what is the probability of any single outcome event. Well, an event that has one outcome is just going to be 1/16th. So if the outcome is, if the event is just one particular event, then it's going to be 1/16th. Okay, now here is there's ways of building up sort of experiments that have sort of 2 layers. One layer, everything is equally likely. That's our classical probability model, in which we have a set of outcomes which are all equally likely. But then they can sort of be grouped, so it looks like that the probability of there's sort of an appearance of we can sort of create an example of something that looks like a non-classical model, and maybe that's a little bit obscure, but this sort of will explain what's going on. Consider an experiment in which 6 red, 4 blue, 3 green, and 2 white marbles are placed inside a box. The marbles of each color are numbered 1 through 6 for red, 1 through 4 for blue, 1 through 3 for green, and 1 and 2 for white. Okay, so first of all, what is the sample space? And what's the sample space size? So maybe the idea is that the sample space is going to equal all of these events. And so the question here is the naming. Anyway, the point is, in each of these, we're going to put down red, blue, green, or white, and so take a moment and at least answer the question of how many, what's the size of the sample space? Okay, so this is a little bit obscure, but we can see that the sample space size is going to be 6 plus 4 is 10, plus 3 plus 2 is 10 plus 5 is going to be 15. Okay, well, we've got 6 red ones. 1, 2, 3, 4, 5, 6, and we could label them 1, 2, 3, 4, 5, 6, and then there's going to be 4 blue, and there'll be 1, 2, 3, 4, and 3 green, and 2 white. Okay. So, I mean, you could imagine that there's going to be that we could say that there really are six marbles, but if you didn't number them, they would just look. They're just you wouldn't be able to tell which one was which. So we'd have like six red ones, three, four blue ones, three green ones, and two white ones, and you wouldn't have the label here. So I think that the ambiguity and the directions here were that we can write in the color in each of these boxes without writing in the number, but the outcomes, if I was to write the sample space, I'd have to have R1, R2, R3, R4, R5, R6, because I'd have to have I have 15 different outcomes. But what you can see is that when it asks the question, let's look at the question, what is the probability of drawing a white marble? Well, it looks like the sample space is you either have a red, blue, green, or white. Well, that you could make the experiment where the sample space was red, blue, green, or white, but then the probability, if these were all identical, then your sample space size of sort of identical ones would just be RG, uh, red, green, blue, and white, W, but then this would not be a classical probability situation because these aren't equally likely. So this is sort of this two-layer situation in which underneath you have like a 15 outcome set, which can be, which on the surface looks like in the experiment looks like a element outcome, but each of these events here, each of these outcomes here is actually an event in this underlying sample space. So that's why you might see this experiment phrased in such a way that it looks like there's four outcomes when there's actually 15. So when you ask what's the probability of drawing a white marble, you have to answer that with the 15 outcome. It's not going to be like 1/4. Okay, so let me give you a chance to write down what the probability is of you getting a white marble. I'm recording. Okay, so now there's two white marbles, even though they're 1 and 2, and so there's 2 out of 15. The number of outcomes in the event a white marble is drawn is 2. The sample space size is 15, so the probability is 2/15. And you can see that the probability of drawing a red marble is going to be the number of outcomes where a red marble is drawn. You can see there's 6 of them, so here you're going to have 6/15 is the probability. Now, here is so you have a white marble probability. So you have an event E white, you have an event E red, and then this event, which is the question I'm going to let you think about for a moment, is what's the probability of drawing either a red marble or a white marble? Well, in terms of that's an event, but you can see that it's an event that is either in this set or this set. So this event here, um, R or W, is going to be E W union ER. So what's the probability of this event occurring? I'm going to give you a moment to. Okay. So now, well, there are 2 white ones and 6 red ones. So in this event, it's going to be W1, W2, R1 to R6. So there's going to be 8. Probably is going to be 8/15. Now, this also raises the question. There's one thing that a requirement for a probability model to be good, as well as the fact that the probability of the sample space being 1 and the probability of the empty set being 0. What it has to be that the probability of a union is equal to the sum of the probabilities of events. If this sets the union of 2 events and there's no intersection between the 2 events, and there isn't, you can't have drawn a white marble and a red marble. The intersection is 0. So as a result, this answer of 8/15 should equal 2/15 plus 6/15. If this wasn't true, and it is, because you can see that this is a common denominator, it's just going to be 6 plus 2 is 8. That if this wasn't true, then we wouldn't have a good probability model. Okay, so that is some comments on that. Let's see if we're almost at the end of these exercises. Let's consider the next, I think the last one in this set. Consider an experiment in which two red, numbered 1 and 2, so we have red 1, red 2, and one blue marble are placed inside a box, which is then shaken. A blindfolded person draws a marble from the box, and the result is recorded, and the marble is placed back in the box. The blindfolded person then draws a second marble, and the second marble is recorded. So what's the sample space? Well, the it's a little bit complicated to think about. Let's think about this, because in the it says enter the outcomes of the following diagram. Label each row with the first draw result and each column with the second draw result. Well, so we could have either in the first draw, we could have red 1, red 2, or blue. And let me maybe do this with a subscript so it isn't so large. Okay, so we have one of the two red ones or blue, and this is the first draw. Now you put them back in, and then you can draw them again. Well, you could get the red 1, the red 2, or a blue 1. So those are the second draw. And so what's intended is then this box here would be the outcome in which you got red 1 in the first draw, red 1 in the second draw. So you draw in here red 1, red 1. I think we can do this together. So you can fill in the, so this is just a mechanism for writing out all the outcomes for this somewhat more complicated situation. So there you have a picture of the sample space, and you can see that the sample space size is, and you might want to, I'll give you a moment to fill that in. Well, it's obviously going to be 9. So there's 9 outcomes. The sample space size is 9. Now, what event corresponds to drawing a blue marble, then a red marble? Okay, I'm going to let you take a moment and write down. Now, this is an event, not a problem. You got to distinguish between events and probabilities. So what's the event that corresponds to drawing a blue marble, then a red marble?